finding out if two triangles are similar. So what do we mean by similar? Well, you've seen this before already. When one shape is an enlargement or reduction of another, we actually call these shapes similar. In math, we use this little symbol to indicate similarity. It's not the equal sign, but it's like a wavy equal sign. Okay? So this is the symbol we use to show something is similar. How do you tell if something is similar? Well, remember, it's an enlargement or reduction. So the corresponding angles of the two shapes must be equal. Or, like what you've seen in the previous topics, like the scale diagrams and maps, the corresponding lengths must be proportional. So before we begin, you should know a few things. When we're talking about triangles, we can name angles in two ways. We can use 3 capital letters. So if I'm asking about this angle here, I could call this angle L. Oops. I wrote this wrong. LKM, or I could also call it MKL, as long as the middle letter K is the vertex or the corner of the angle. Or we just use the middle letter by itself, so angle K. Okay? Now in this particular example, using the middle letter is fine, but can you think about where using the 3 letters might be more advantageous than just using the 1? Sides of a triangle are named with 2 letters that make up a side. So if I'm looking at this side here, we can call that KL, or we can also call it LK. Most people like to use the alphabet, and if I'm thinking of the alphabet, A, B, C, D, E, F, G, H, I, J, K, L. K comes before L, so this is the preferred way of writing it. Okay? So I'm just going to ask you to refer to angles this way and sides this way so that we can describe what's going on. So let's look at these 2 triangles. Okay, I've got triangle A, B, C, and D, E, F. I'd like you to identify the corresponding side and angle. So which angle in triangle ABC, let's say angle A for instance, matches up with which angle in triangle DEF? Right? And same thing with the sides. Which side in triangle ABC, let's say AB, matches up with the other side in triangle DEF? So, AB, I hope you can see, corresponds to the side DE. I hope you can also see that side BC corresponds to the side EF. And I hope you can finally see that the side AC corresponds to the side DF. That's why we need to figure out the corresponding sides so we can actually find the proportion. Similarly, if I'm asking for corresponding angles, well, angle A here, that's the 50 degrees. That must be also 50 degrees in our enlargement or our reduction. So this must be angle D. Angle B is 100, and so is angle E. And angle C is the remaining one. That must be equal to angle F. So in this triangle, the corresponding sides are those, and the corresponding angles are the ones there too. And now, can we write the ratio of the corresponding sides in lowest terms? So when setting up ratios, start by placing one triangle's corresponding side in the numerator and the other in the denominator. Does it matter which one goes on top and which one on the bottom? No, just be consistent. So in this case, if I call my first triangle ABC, then that means all the lengths for ABC are on top, and the second triangle, which is DEF, all those go on the bottom. Okay, just to be aware. So let's compare the lengths of AB to DE. So if I were to now compare AB to DE, I get the ratio of 6 to 4.5. If I were to use now BC to EF, so comparing those sides, I get 8 over 6. And if I were to finally choose AC over DF, I'd get 10 over 7.5. And in every single one of these cases, if I were to reduce, I would get the following. And you can also do this on your calculator. It's up to you. 6 divided by 4.5. That's 1.33333. And 8 divided by 6, I'll tell you, is also 1.33333. Going on forever. And the same thing here. So because the ratio is the same, that means that triangle ABC must be similar to triangle DEF. Okay? And why? I'll say because the ratio of all sets of corresponding sides are equal. Okay. All right. So turn the page and let's try some examples. Here's example number 1. It says determine if triangle ABC is similar to triangle EFG. So let's look to see what we can figure out. Let's look at the corresponding angles this time first. So I'll say angle A seems to match up with angle E. Okay, that's good. They're both 90. Angle B matches up with angle F. So that's good. And then finally, angle C must match up with angle G, because third angles in a triangle must equal each other. So we've got the sides, the angles that correspond. Let's look at the sides. So I'm thinking now side AB, that's this one, corresponds to EF. So AB corresponds to EF. I see AC corresponds to FG. And finally, BC corresponds to, I'm sorry, did I say FG earlier? I meant EG. Oops. And then this one should be FG. Yeah. All right, so let's take a look. If they're similar, we've got the corresponding parts. That's great, but now let's look at the ratio. So I'm going to take a look at AB and finding its ratio with EF. AB, the length is 12. EF, the length is 4. And that reduces to just 3/1. AC with EG. AC is 9. EG is 3. That's also 3/1. Looking good so far. And then finally, BC corresponding with FG. 15/5. That's equal to 3/1. Yeah. Ching-ching. All three are the same. They're 3/1. So therefore, and I'll use these 3 dots to represent therefore, triangle, I'll say ABC is similar to triangle EFG as the ratio of corresponding sides are all 3/1. Or you can write down 3/1 like that. Cool. And why is this helpful to us? Because if you know triangles are similar, just like before, we can use the proportion to help us determine unknown dimensions, just like what we did with maps and scales and everything else beforehand. So in the similar triangle below, if I'm asking you to solve for the missing sides of x and y, let's see if we can do it. Now notice I've already told you this time they are similar. So now your job is just to find the corresponding sides that are similar. So this side of 3, what does that connect with? Yeah, the 7.2. How about this side of the 4? What does that connect to? Yes, the y. And finally, the side of 5, that connects with, yes, the x. So as long as you find the corresponding matches, then life is actually pretty straightforward. So it says identify the corresponding side ratios. I just did that. I did it in colors this time, okay? If you want to use letters, sure. You can call this A, B, C, and D, E, F, whatever you wish. And what I've just told you is AB corresponds with DE. And I said BC corresponds with EF. And I said AC corresponds with DF. Okay? And now it says you can solve for each variable by creating equations with these fractions. So which one of these pairs of ratios do I have both numbers? Because with both numbers, I can create the fraction. And if you're thinking, yes, it's the AB with the DE. It's this set that has both numbers. So I can say now AB divided by DE is equivalent to 3 over 7.2. And there's my, kind of like my scale factor, you know, like that kind of thing. So here's my ratio. And if I'm making this equal to, let's just compare now the blue stuff, which would be AC over DF, that would be 5 over X. So using these two sets now, 3 over 7.2 equals to 5 over X. Notice you've got a nice proportion. Go ahead now, solve by cross multiplying. 3 times X equals 5 times 7.2. 5 times 7.2, I believe, is 36. We'll divide both sides by 3, so in this case, X equals to 12. Do I have units here? No, so just 12 units long. And similarly, now I'm going to ask you to try to find out why. I will start this off by just writing the ratio for you, BC over EF, but I'm hoping you can do the rest. So go ahead and try this, please, on your own, and double check back with me when you're done. And if you got it right, like I said before, give yourself a pat on the back.